multiplying 59 times 66. How will I set that area model up, Ansley?
You put 66 on the top and 59 on the side.
Okay. All right, so I'm making my area model. What shape is an area model?
A square.
Is it a square?
Rectangle.
It's a rectangle. And we know that one of the rules of a rectangle is that the opposite sides have the same length. So that tells me if this part is 60, what's the opposite part there? 60. If this part is 6, what is the opposite side? 6. Okay, and on our side, we had 50 and 9, which adds up to 59. If this is 50, what will this side be?
50.
That's going to be 50 as well. If this is 9, what is this? 9. If it helps you to go ahead and label all the way around that rectangle, do it. If that helps you see what you're supposed to be multiplying, that's a quick and easy thing to do, isn't it? All right, so Ansley, what am I going to do to find the area here?
50 times 60.
50 times 60 is 3,000. I multiply the length, which is 60, times the width, which is 50. 6 times 5 is 30. And we have 2 more zeros, so 3,000. What am I doing here, Dylan?
So then you're adding 50 and 6 together.
I'm adding 50 and 6.
You're timing.
I'm multiplying.
Yeah, you're multiplying it together.
Mm-hmm.
And so this is kind of easy because you can do, if you take off that 0, you can add that later.
Mm-hmm.
You can add 5 times 6, that's 30.
5 times 6 is 30.
30. And then you put that 0 on it and it's 350.
You said 6 times 5 is 30.
I mean 300.
300.
Wait, but there's the other 0.
No.
Okay, let's look. We're doing 6 times 50.
Yeah.
6 times 5 is 30.
I didn't see the problem.
And then we have 1 more 0 to add, so that makes 300.
I didn't see the problem. I just saw the 60 times
Okay.
50.
Yeah, we on 60 times 50, we did get 3,000. 6 times 5 was 30, and we added 2 zeros. All right, so now let's look at this part right here. What am I multiplying here, Olivia?
9 times 6.
9 times 60. What is 9 times 60?
58. Well, 56. 54.
54. 9 times 6 is 54.
You add 0 to it.
And I have 1 0 to put on the end. So that's going to be 540. And how about this last section right here, Harper? How am I going to find the area of that part? How about we start paying attention so that we know where we're at? What do we need to do here?
9 times 9 is 81.
Why would we multiply 9 times 9 to find the area of this section?
Because the other side, because this side is 90, 9, and the other side's 90.
What is the length?
6.
6. What is the width?
6. 9.
9. So what do I need to multiply?
6 times 9.
6 times 9, which is
51. Oh, 81.
6 times 9. Help him out, Alexis.
54.
54, thank you. So this part is 54. Now what do I need to do to find my answer, Harper?
You add all of it.
I'm going to add all of those parts together. So I have 3,000 plus 300 plus 540 plus 54. If I look at all those ones and I add them together, how many ones would I have?
You
4.
have
4.
You have
0 plus 0 plus 0 plus 4 is 4. If I look at my tens, 0 plus 0 plus 4 plus 5 is 9. Now if I go to my hundreds, 0 plus 3 plus 5 is 8. And then the thousands, I only have a 3. So my answer is going to be 3,894. Okay, did you have a question?
No, I'm saying I know the question.
Okay. All right, any questions about area models?
no, ma'am.
All right. All right, so sometimes these questions trip us up a little bit, but they shouldn't. So I want everybody to really focus and let's talk about what's happening. We're using the associative property to solve this multiplication problem. 4 times 6 times 2. What does the associative property say or mean? Does anybody remember? Olivia?
Same as a thing.
Well, it's going to be the same no matter how what? Jacob?
How you do it.
Yeah, no matter how I group them, no matter which numbers I multiply together first, or which parts I put together first when I'm multiplying, I can group anything I want together and I'm going to get the same answer. So this equal sign here, what does equal mean?
It's equal to.
It's equal to, it's the same as. So I'm ignoring everything except the top line right now. I have 4 times 6 times 2 equals, or is the same as 4 times what? Times 2. What do I need to make A so that both sides of my equation are balanced or are the same, Ansley?
6.
6. So A is going to be equal to 6.
Yep.
Okay, so we've taken care of this top line. We're good to go there. Okay, so now we're ready to solve. If I were going to solve this problem, I'm going to start with the left side of the equal sign just because we read from left to right. So for me, it's easier just to start on the left. So if I only look at this part right here, 4 times 6 times 2. What would I do first to solve that, Cash? Cool. What would I do first to solve this? Times what?
6 times 2.
Yeah, 6 times 2. How did you know we needed to do 6 times 2, Cash?
Because there's a time.
Yeah, it's got those parentheses around it. And the parentheses say to do what's inside of them first. So 6 times 2 is what, Cash? Tell us again. Do what?
12.
12. So what's B going to equal?
12.
12. Have I done anything with my 4 yet?
No.
No. So when I put 12 for B, I still have to multiply that times 4, don't I? Okay? Now we're going to do the same thing. We're just going to look at this left side. I'm sorry, at the right side. We've taken care of the left. So now we're going to move over here to the right side. What do I need to do first to solve what's on the right of my multiplication or my equal sign? Jacob?
You multiply 4 times 6.
Yeah, those parentheses tell me I'm going to do 4 times 6 first. What is 4 times 6, Owen?
4 times 6 is 24.
24. So what's C equal to?
24.
24.
No, you're right.
Okay. Have I taken care of that multiplying by 2?
No.
No, I've only done what's in parentheses. So I have 24 times 2 left to multiply. On the left side over here, I have 4 times 12 left to multiply. Okay, so now I'm ready to go to my next step to finish solving. What's 4 times 12? What is it, Ansley?
48.
48. What is 24 times 2, Christopher?
48.
48. So what is D equal to?
48.
48. So is our equation true?
Yes.
Yes.
Yeah. 48 is the same as or equal to 48. So that proves that the associative property works. Did I multiply my numbers in the same order?
Yes.
On both sides? Did I multiply them? No.
Both sides, but
Yeah. But it didn't matter. I still got the same answer. Yes, Sam.
So like an example would be like 3 plus 2 is equal to 2 plus 3, right?
Yes, that's the associative property of addition. You're exactly right. All right, questions on that?
No.
You'll have one like that to do tomorrow. And you'll have one like this to do on your daily math quiz Friday. Okay?
Now I get how I got it wrong. I just switched the 2 on B and C around.
Okay.
And I didn't get the right answer on the D.
That's as long as you figured it out.
Doing these kinds.
All right. Let me make this a little bit smaller so that we can see. Good. All right. Now let's check number 5. We're looking at the diagram and answer that matches this problem. There are 42 chairs in the classroom. That is 7 times the number of tables. How many tables are in the classroom? So let's look at what we have. There are how many chairs? 42 chairs. Then it says
there's 7 times.
that is. What does that is? Tell me.
It means that
What math symbol could I replace is with, Amy? Is means divided by? Equals. So 42 equals, okay, it says that is, now I have 7 times. So what would I replace 7 times with in a mathematical equation, Harper?
7 multiplication.
Yeah, 7, and then the multiplication sign. So that is 7 times the number of tables. And we don't know the number of tables, do we?
No, we do not.
So we can use a variable. We'll just use a t for tables. So if I just take exactly what this question says, 42 chairs, that is, tells me equals 7 times the number of tables. I get the equation 42 equals 7 times t, or the number of tables. How could I turn that multiplication sentence around into another mathematical equation that is equal or equivalent, but that my missing number, the number of tables, is all alone? How can I turn that around, Olivia?
You could do T times 7 equals.
Okay, but would that make the t by itself?
No.
What if I want the t to be by itself? How can I do that?
So something times T.
What's the opposite of multiplication?
Division.
Division. So what can I do?
Divide.
So I can do
42 divided by.
What would I have to divide 42 by? 7. That's the same as 42 divided by 7. I just used the opposite operation to turn that around. So which one is going to give me the correct answer, Ansley?
Option 2.
Option 2, 42 divided by 7 equals 6.
Yeah.
Okay, that shows us that there are 7 groups of 6 chairs, and that would mean that there are 6 tables in the classroom. Very good. All right, any questions?
No.